Now see the part 4 of ionic equilibrium. Part 4 of ionic equilibrium. So now look at the question number 12. Equal volume of 3 acid solutions are given. Of pH is given, right? So 3 acids are given there, whose pH is given. Of pH, first pH is 3, second one is 4, fifth one is, third one is 5th, are mixed in a vessel. So they are of equal volume, suppose V. So total volume will become V plus V plus V. So it will be total 3V. So what is the H plus ion concentration? So it is asking about H plus ion concentration. Hydrogen ion concentration. Hydrogen ion concentration. So it is also asked in 2008, question number 12. Now see whole explanation. So as we know, pH is equal to minus log of H plus ion concentration, right? So for pH is equal to 3. So write here pH in the formula. So pH is 3 is equal to minus log of H plus ion concentration, right? So here for first I will explain. So this minus will come here. So it will be minus 3. Base is 10 here, right? So it will be log of H plus ion concentration of the base 10, right? So when we convert log into exponential, this log will be here in the power. So it will be 10 raised to minus 3 of H plus ion concentration, right? So see the observation here. When pH is equal to 3, H plus ion is concentration is 10 raised to minus 3 only. So in the similar manner, when pH is equal to 4, so here concentration of H plus will become only 10 raised to minus 4. In the similar manner, pH is equal to 5. So concentration of H plus ion will be 10 raised to minus of 5. Right. Now we have got the concentration of H plus in the all the three cases, right? So what will be the value of now when we mix it? See in the next slide. So see, when all the given solutions are mixed in a equal volume, so it will be what? Right. So concentration will be M equal to. So first concentration is 10 raised to minus 3. Next one is 10 raised to minus 4. And third one is 10 raised to minus 5. And divided by 3. Right. So now see the explanation now. So how will you find M? M means molarity we are finding here. So it is nothing but molarity. So see here, this can be written as 10 raised to minus 3 into 1. First one. In the similar manner, second can be written as 10 raised to minus 4 into 10 raised to minus 1. No, please write this one. This is correct. This can be 3. This will be 3. I have split this 10 raised to minus 4 into two parts, 10 raised to minus 3 and 10 raised to minus 1. In the similar manner, 10 raised to minus 3 into 10 raised to minus 2. Right, divided by 3. Right, so molarity is equal to, this is not M, this is 3. Understood? So take common from all the three terms. So it will be 10 raised to minus 3 into 1 plus. This will become 1 upon 10. So 1 upon 10 is nothing but 0.1. So it will be, you can write then one step add. So 10 raised to minus 1 can be written as 10. And 10 raised to minus 2 can be written as 1 upon 10 raised to 2. I have taken this 10 raised to minus 3 from common. So divided by 3. So M will be nothing but 10 raised to minus 3. 1 plus 1 upon 10 will be 0.1. 1 upon 10 raised to 2 will be 0.01. Now add these three terms and divide by 3. So it will be how much? 10 raised to minus 3. So it will be 1.11. So it is 1.11. 1 divided by 3, right? So this is your molarity. So now see the next step now. So as we know, when it is mixed with the volume, so it is molarity into V1 plus V2 plus V3 is equal to initial. This is your final, right? Molarity into volume is equal to initial. So initial will be M1 V1 plus M2 V2 plus M3 V3. Now put the value now. So every V1 equal to V2 equal to V3 is equal to V, right? So M, these are equals, so it will become 3V is equal to. Now put the value, right? From these three terms, volumes are constant V1, V2, V3. M1, M2, M3 are different. So which I'm taking with red, that one is different only. So take V as common and M1 in right in the bracket. So it will be M1 plus M2 plus M3 into V, right? So this V and this will get cancelled. So M is equal to nothing but we know the value now, right? So M1 is 10 raised to minus 3 plus 10 raised to minus 4 plus 10 raised to minus 5. So these are the concentration, right? And volume resultant we have got, right? So this value is how much? Is equal to 3m, right? So calculate this one. So it will be take minus 10 raised to minus 3 common. So it will be 1 plus 0 0.1 plus 0 0.01. 10 raised to minus 3. So it will be 1.11. So m will be equal to 10 raised to minus 3 divided by 3. So this will be the m. So calculate this part. So you will get how much it is 3.7 into 10 raised to minus 4. Right. So this will be the final molarity of the mixed solution. So write the whole explanation. Now see the question number 13. So 13. A weak acid HA. Weak acid, that is HA. Right. Has a equilibrium constant K is given, that is 1 into 10 raised to minus 5. Right. If 0.1 mole of this acid is dissolved in 1 liter of water, right, 1 mole of this acid, so it is mole is given, that is 0.1 mole of acid is dissolved in 1 liter, so it is dissolved in 1 liter. The percentage of acid dissociated at equilibrium is, so you have to find the alpha, basically percentage dissociation, percentage dissociation, right? So it is asked in 2007. So see the explanation now. So it will be what? So you can write this as, this is your HA, weak acid, right? So it dissociate into H plus plus A minus. So it is initially given, that is 0.1 mole. It is not formed, so it is 0. This is your at initial. Now see for the equilibrium part. So at equilibrium it will be 0.1 into 1 minus x. This is 0.1x, 0.1x, right? So write the equilibrium constant for this reaction. So it is K is equal to concentration of H plus into concentration of A minus, right? So in numerator, reactant product part comes. So this part we have written, right? So it is divided by now concentration of HA, right? Now put the value of each term now. So it is K is equal to H plus concentration, we know, right? So this is your H plus concentration and this is your A minus concentration. So it will be 0.1 x, right? 0.1 x divided by 0.1 into 1 minus x. So as we know, x is very small, so you can neglect x. So 1 minus x will become 1. So this will become 1. So answer is, as we know, k value is given here in the question. So you can find the x in the very simple manner. So k, put the value k, 1 into 10 raised to minus 5 is equal to, this is 0.1. So this point is cancelled with this one. So 0.1 into x square. This x into x multiplied, right? So x square will be 10 raised to minus 5 divided by 0.1. So remove this point. So we'll get here 10. So this will be 10 raised to minus 4. So x will be the under root of 10 raised to minus 4. So it will be 10 raised to minus 2 is your x, right? So this is your degree of dissociation. So if you find the percentage, then multiply with the 100. So x percentage will be 10 raised to minus 2 into 100. So this and this will get cancelled. So it will be 1% only. So how much HA dissociated due to the weak acid? Only 1% of 100 moles. Now see the question number 14. Calculate the pOH. Calculate pOH of solution at 25 degree Celsius that contain hydronium ion H3O plus as 10 raised to minus of 10 molarity, right? So it is asked in 2007. So see now the explanation. So as we know, right? So H3O plus means it is nothing but is your H plus ion concentration, right? It is 10 raised to minus 10 molarity. And we know pH is equal to minus of log of H plus concentration. So put here H plus ion concentration. So it is 10 raised to minus of 10. So this power will be coming out. So it is minus of minus 10 log of 10. Log 10 we know that is 1. And this minus and minus will become plus. So it is 10. So pH of 10 is equal to nothing but 10. Right. So we have to find pOH. And as we know, the relation between pH plus pOH is equal to nothing but it is 14. So pH is 10 plus pOH is, you can find it out easily from this formula. So it will be pOH is equal to 14 minus 10. So then it will become 4. pOH value we have got now. Right. So very simple. We have to just remember the two formulae for solving this question. This equation, right, and this relation pH is equal to minus of log of H plus ion concentration. Now see the question number 15. So the hydrogen ion concentration of 10 raised to minus 8 molarity. So concentration of H plus is 10 raised to minus 8 molarity of HCl. Right, aqueous solution. Temperature is given, that is 298 Kelvin. So equilibrium constant for water is given, that is 10 raised to minus 14. So find the hydrogen ion concentration when it is in the aqueous solution. So see, so when HCl dissociate, it forms H plus Cl minus. Right. So initial concentration of this HCl is given, that is 10 raised to minus of 8. So it is not formed, so it is 0 0. So it is at the initial concentration. So when it is at equilibrium, as we know, HCl is a strong acid, so it will dissociate completely due to the strong, right? So it will become 0, then it will be 10 raised to minus 8, and this will be 10 raised to minus 8. So it is at the equilibrium, right? So now see the next part. This part is your case 1. Now see for the when water is dissociated. So this is your water, dissociate H plus OH minus, ion concentration, right? So as we know, at equilibrium for the water, concentration of H plus and OH minus is equal to 10 raised to minus of 7, right? So you can just observe, here is also H plus, here also we are getting 10 raised to minus 7 molarity, right? So when we have to find the whole H plus ion concentration, then we have to add this H plus and this H plus ion concentration, right? So what will be the value then? It will be 10 raised to minus of 7 plus 10 raised to of minus 8. So see, so it will be 10 raised to minus 7 plus 10 raised to minus 7 into 10 raised to minus 1. 10 raised to minus 8 we have written. So take 10 raised to minus 7 as common, then it will become 1 plus 1 upon 10, right? So it will be 1 plus 0 0.1, 10 raised to minus of 7. So it will be 1.1, 10 raised to of minus 7 concentration. Understood? So right up to this point then. Now look at the next term, that is 16. At 25 degrees Celsius, at 25 degree Celsius, dissociation constant of the base is given, that is 1 into 10 raised to minus of 12. It is in the form of BOH. The concentration of hydroxyl ion in, so you have to find hydroxyl ion concentration, means OH minus concentration, right? 0.01 molarity aqueous solution. So concentration of this value initially is given, that is 0.01 molarity. So it is asked in 2005 NEET. So see the explanation. When it dissociate BOH, so when it dissociate into B plus OH minus, so it will be the equilibrium constant of base will be B plus concentration of OH minus divided by concentration of BOH is equal to, right? So it dissociate into complete ions. So this concentration and this concentration will be the same. So we can write as OH minus concentration square divided by initial concentration, that is 0.01, right? And as we know, equilibrium constant for the base, it is given, that is 1 into 10 raised to minus 12. So OH minus concentration square is equal to 0.01 into 10 raised to minus 12, right? So solve this one, so remove this point, so you will get here 100. So take in the upper part, so it will be 10 raised to minus 14 of OH minus concentration square. So concentration of OH minus square will be the under root of 10 raised to minus of 14. So it is 10 raised to minus of 7 concentration of OH minus. So this will be the value of OH minus concentration. So write the whole explanation.